Hi everyone, my name is Wayne Freeman with Microchip Technology, and I've got some exciting stuff to share with you today. We're going to talk about saving more. I know, you've heard that phrase early and often, but I promise to show you some new technologies available in the 8-bit market that are going to help you build your design more efficiently and save money while doing it. Let's start with an interesting factoid. According to a recent survey by Design News magazine, 47% of engineers who responded feel they are underpaid and overworked. Macroeconomic changes over the past few years have caused companies to focus on efficiency of operation. This change amplifies several common challenges in engineers' daily lives. The most prevalent being things like power budgets. Manufacturers that adopt green initiatives make it imperative for engineers to place emphasis on the lifetime power consumption of their designs. Product packaging. Sleeker, more consumer-friendly designs are common in many applications. Now, while they're attractive, they also give engineers less room to place components on a PCB. Nowadays, a designer must give extra attention to component count, placement, and size. And of course, the big one, cost constraints. A perennial concern of any company is its bottom line. The recent past has seen an intensified focus on cost to the point where every penny matters. All of these place significant stresses on product development cycles. Microchip's product families are geared toward breaking barriers to engineer success. We began by making nanowatt XLP the new industry standard for low power consumption. Then we eclipsed that standard with several product families that consume a fraction of the XLP benchmarks. In addition to achieving ultra-low current consumption in active mode, we help engineers save space by offering some of the smallest packaging options available on the market. We continue to change the 8-bit market by integrating peripherals designed to clean up customers' boards of discrete components, thereby enabling a smaller, more efficient MCU to perform an engineer's chosen tasks. Through techniques implemented over many years of development, Microchip has introduced some of the world's most efficient microcontrollers. In fact, achieving decades of battery life off of a single coin cell is an easy feat for many PIC MCUs. Did you know that you can put a PIC MCU through a virtual battery life test using software available online? Using the battery life estimator, you can create application scenarios and get a pretty good picture of how much power you can save using a PIC MCU. Go to www.microchip.com/BLE for more details. How do we help our customers save more power? Well, we focus on several areas. The first being baseline current consumption in sleep. A large portion of battery-powered applications conserve energy by sleeping various components during the majority of operation. Our products feature sleep currents as low as 20 nanoamps for the most efficient sleep mode possible. Secondly, we place high importance on active current consumption. When running, Microchip MCUs can consume less than 30 microamps per megahertz in active mode. This allows them to meet the most stringent power requirements. Our products for the 8-bit market can also operate at up to 64 megahertz for the most efficient use of time spent in active mode. We offer low voltage operation. In fact, many of our MCUs are capable of full operation at 1.8 volts. Then, we add low power timekeeping peripherals and monitoring circuitry. Our real-time clock, low-power oscillators, and watchdog timers consume as little as 500 nanoamps during operation. Of course, many applications need a low-voltage safety net, so we've engineered our BOR, or brownout reset circuitry, to consume very little current. These elements combine to save customers more power. We help our customers save more space by making our products as small as possible. Using the 2x3 DFN packaged products as an example, we can squeeze quite a bit of performance in very small spaces. In fact, nearly 1,000 of them will fit onto a standard sticky note. We also offer small packaging options throughout our pin count range, with footprints as small as 1.6 millimeters by 2.4 millimeters. We help customers save more money by providing peripherals that encourage our customers to combine as many system functions onto a single chip as possible. These peripherals include internal clock sources, onboard temporary data storage, onboard analog, a variety of communications peripherals, digital control modules like pulse width modulators, and new modules we call PIC Microcontroller Exclusive Peripherals, which really set Microchip MCUs apart from the rest of the pack. Each of these new peripherals is designed to revolutionize the 8-bit market by allowing more functions to be implemented in smaller, more efficient, and cheaper MCUs. They include the CLC, or Configurable Logic Cell, which offers easy on-chip combinational and sequential glue logic for your next design. The NCO, or Numerically Controlled Oscillator, is the most precise PWM available on an inexpensive 8-bit MCU. The CWG, or Complementary Waveform Generator, allows you to perform half-bridge motor control or power supply control on an inexpensive MCU. And last but not least, the CTMU, which stands for Charge Time Measurement Unit, is an all-purpose integrated peripheral for measurement applications. In this section, we'll go into a bit more detail on how these peripherals function, the benefits they bring, and provide some application examples for each one. For many years, PIC microcontrollers have been used to reduce BOM cost by lowering the component count of various applications. Often, a bit of glue logic, a stray 555 timer, or a data modulator can be integrated directly into a PIC MCU. Now, Microchip offers products that will perform these functions with zero code overhead, using the new configurable logic cell. The CLC functions as a mini programmable logic device on board a PIC microcontroller and can be used to create custom, combinational, and sequential logic. Now, due to its flexibility, the CLC can be easily configured and used as an AND gate, OR gate, XOR gate, a latch, or a flip-flop. Now, these can be set up using a simple graphical user interface available online at microchip.com and can be reconfigured on the fly in user software. Because the CLC operates independently of the core processor and requires no program or data memory once configured, it's extremely efficient and consumes very little power. It can also be operated in sleep mode. The CLC can take any peripheral or any I/O as an input, and the output can be sent to, well, likewise, any peripheral or any I/O pin. A pair of CLCs can be combined to implement more complex logic functions, such as a data modulator. Other common CLC applications include power sequencing, Manchester encoding, and implementing logic bug fixes in ASIC silicon. Quite often, cost-sensitive systems have their budgets exceeded when a single system requirement forces designers to use a more expensive MCU. This is common in lighting systems and low-cost sound generation applications like fire alarms. Both of these applications require an extremely precise PWM to generate the necessary frequencies required for efficient ballast control or tone generation. Usually, the words high precision go hand in hand with the word expensive. Now, Microchip has an ingenious solution to this problem. Called the NCO, or Numerically Controlled Oscillator, this new module is basically a fixed duty cycle PWM with its frequency controlled by a register value. Now, this arrangement is very low cost, yet it allows an extremely linear response from 0 to 500 kilohertz in tiny 15 hertz increments. The NCO can significantly reduce the cost of implementing an efficient control mechanism for fluorescent lighting. Or, when used with LEDs, the NCO can provide the precision necessary to match color temperature. The NCO's true linear frequency response and increased frequency resolution of up to 20 bits make it a solid choice for implementing low-cost switch mode power supplies. And speaking of power supplies, just about everything with a motor, a light, or a power supply uses something called a transistor switched circuit. The most prevalent of these is the half bridge because of its low cost of implementation. We all know that using an MCU to drive these circuits makes them efficient and flexible. MCU-based control of a half-bridge switching circuit requires, number one, a primary pulse train to drive a single transistor, and a complementary pulse train with a bit of dead time in which both transistors are off to avoid unwanted current shoot-through. While it is possible to use a cheap MCU to bit-bang this series of pulses, keep time, restart in case of a mishap, and insert dead time, the MCU will likely have all of its resources consumed performing this simple set of tasks. Luckily, Microchip has introduced a new hardware module for cost-optimized complementary waveform generation called the CWG. It generates complementary, non-overlapping waveforms and offers a few enhanced capabilities. These capabilities include auto shutdown and restart, polarity control, and deadband control with independent rise and fall time control. Now, the CWG is an independent module. And what this means is that it can be set up to generate the complement of a number of signals, such as the NCO, the CLC, or a comparator, in addition to the standard PWM. This flexibility gives engineers the room to innovate. Its size, allows a cost-effective small MCU like the 6-pin PIC 10F322 to perform the same function as a much larger MCU. Our next exclusive peripheral is the charge time measurement unit. At its most basic description, the CTMU is an on-chip constant current source. It usually works in conjunction with the ADC to enable capacitive, inductive, resistance, and time measurements. Now this enables any PIC MCU with the CTMU to perform a wide array of high-precision measurements without the expensive external hardware usually associated with those applications. The CTMU module can also be configured to support capacitive touch for easy implementation of buttons, keys, and sliders. The CTMU helps you save more because it uses fewer components than a discrete implementation, thereby reducing system cost. Because of the versatility of this peripheral, it can be used to implement many different types of sensors. The CTMU can easily be configured to support any application that requires a precise time or capacitive measurement. This long list includes humidity sensing, pressure sensing, touch sensing, flow rate sensing, and temperature sensing. In fact, the CTMU can be used to turn a low-cost PIC MCU into an ultrasonic imaging powerhouse. In such an application, the CTMU would be used to measure the time between transmitted and reflected impulses. This information is then continuously fed in real time to a graphic processor to create an image. This can be implemented as an ultrasonic microphone using very few external components. These exciting peripherals, features, and more are available on several new PIC MCUs for the 8-bit market, ranging from 6 pins all the way to 100 pins. I'm out of time today, but feel free to navigate over to www.microchip.com/8bit to find the latest products available with nanowatt XLP and our next generation peripherals. Thank you for your interest in Microchip.